Hello guys, welcome to another video in the series of coding. We are going to do today's problem of the day on Geeks for Geeks. So you are given a binary tree of size n. You have to extract all its leaf nodes to form a doubly linked list. Okay. And then you have to modify the original tree to make the DLL, thus removing the leaf nodes from the tree. Consider the left and right pointers of the tree to be the previous and next pointer. So for example, if this is the tree, you have to basically modify it by removing the leaf nodes. 4, 5, 6, 7 are the leaf nodes. All these leaf nodes will be gone and only 1, 2, 3, this portion of the tree will remain. And the leaf nodes, which are the bottom nodes, which don't have any of the children, these nodes will be gone and only 1, 2, 3 will remain. Okay, so this is a modified tree. And then this is the doubly linked list. So basically 4 will be connected to 5, 5 will be connected to 6, 6 will be connected to 7. But in this order, that is the right of 4 should be 5, right of 5 should be 6, right of 6 should be 7. Okay, so just see these arrows. Right of 4 is 5, right of 5 is 6. Okay, so right of 5 is 6, right of 6 is 7, but also in the reverse order. It's a doubly linked list. So left of 7 is 6. Okay, so we have 7 and then we have left of 7 is 6 and then we have 6 and 5. So if you take 6 and you take left of 6 is 5. Similarly, left of 5 is 4. So you take 5. You have to make a connection here and make left of 5 is equal to 4. Okay. So how do we solve this problem? So the simple way to solve the problem is do the traversal, right? Start from the first node and keep on calling the function unless you reach the end, right? So let's say you're starting from the root, you keep on calling the left child of it unless you reach the end. Once you reach the end, okay, both its children are null. So we'll check the condition. If both the children are null, this node should be removed. Okay, so if both the children are null, in that case, first of all, we will create another new answer node. Okay, we are going to start with answer and we are going to mark it as 4. Now we also have to remove this node from the tree because the tree should only contain this particular 1, 2, 3 and the leaf node should be removed. So what we will do, when we are at this particular node, we will return null. So when we are returning back after traversing this node, instead of returning this node, we will return null. So basically this node will be removed. Okay, and then we'll do the traversal again. So we are basically doing a proper traversal where first we traverse the root, then we go to the left. After traversing the left, once we finish traversing the left, we will come back to right. Okay, so that we are doing the proper traversal, right? Order wise traversal. So it's a proper traversal that we are doing. So once we are reaching the root node, okay, you come to the left, you again go to the left. Now in the left, when we are reversing back and coming back to the node, we will return null. Okay, now we are standing at this node in the traversal order. First we are traversing the root, then it is left, then it is right. Okay, so when you are standing at this particular position, now we will go to the right side. When we are going to the right side, again both of its children are null. So what we are going to do is we are going to take this node. That means this is also a leaf node. Okay, this is also a leaf node. So connect it. So the right of the okay, let's take a pointer current. So the right of the current pointer will become equal to 5. Okay, 5 is the value here, and then the left of 5 will become equal to the current which is the original current. And after doing this thing, you can shift the current to this. Okay, and after this operation, just send back null. So this node will also be removed and then you come back here. Okay, so we do the traversal, these nodes are finished, you come back here. Now it will call its right, then this guy will call its left. Okay, and then this is also a leaf node because both its children are null. So again we'll do the same process. We will make the right of current, okay, we will make it 6, and also what we will do, the left of this will be made 5. Okay, and then current will be shifted. So this is the doubly linked list as of now, 4, 5, 6. Okay, and again this is a leaf node. So in this case, since this is a leaf node, we are going to erase it. By erasing, what we are doing, we are simply going to return null. So whenever we return null, this will attach null to it. So this leaf node will be erased. Okay, now we come back here and this is also 7. Again we do the same thing what we did. We make the right of current equal to 7, and to this node we make the left equal to current. After that we shift the current. Okay, so this is the doubly linked list and answer is pointing to the head. So this is the doubly linked list which we wanted. Okay, and then we'll remove this node by sending a null back to the function. So now the work is done. So this is the logic. Let us see the code of it. So basically we have a function So answer is going to point to the head of the doubly linked list. Okay, this is the head, right? So we need a variable answer that we need to return, which will be the head of the doubly linked list, and we need another variable which is going to be current, which will keep on traversing as discussed in the logic. Okay, if we return current, we will be returning this pointer, but we actually want to return the head, which is the answer. So we have to return answer. So you'll return answer. Okay, now we are calling a function which will do all the logic that we just discussed. So this is the function that we have. So this is the simple traversal. For doing a simple traversal, basically what we are doing is, see, if the root is null, we have to return null, right? Because if the root is null, it doesn't have children, you just have to go back from here. Okay, but if it is a leaf node, okay, so this is the code for it being a leaf node. If it is a leaf node, that means its left child is also null and its right child is also null. This is the condition for checking leaf node. So if this condition is true, it's a leaf node. In that case, see, if your answer is null, that means you are starting at the first point. Okay, if you are starting at the first point, if you don't have anything, that is, first you want to insert 4 in this particular case. So if your answer is null, you have to just insert 4 and move forward. Okay, so if your answer is null, just insert the value of the current node, take a new node and make that as the answer. So you're just declaring, this is just initially declaring and creating a new answer node, and current is also pointing to answer. This is in that case for the first time whenever you see a leaf node. Okay, this is the first time when you see a leaf node, first time you see a leaf node. In all other cases, right, in all other cases you have to do the processing. Next time you see 5, for example, what you're going to do, see, there is current. Okay, current's right is currently null, it doesn't have anything, but here you have to make it 5. Okay, so right now the right of current is null. Okay, current doesn't have any right or left, so in this case you have to make current's right. Okay, this connection you have to give. So you have to make current's right equal to the new node, which is the value of the current root. So in this case, when we are doing this processing, the right of this particular node will become equal to this node. So 4 will have right 5. Okay, and after this node, right, this node which is current's right. Okay, this node is current's right. So the left of this node should be equal to current. Okay, so that's what I'm doing. So current's right, left of that node should be equal to current. After you have done this processing, you have made both the connections, left and right connections, you can shift your current. So this will become your new current. That is the logic which we just discussed. This will become your new current. So current is equal to current's right. So that's it. This is the simple logic which is the crux of this entire problem. And what you are doing is, if you have reached a leaf node, you have to remove it. Okay, you have to remove it. So as we were discussing in the logic, whenever we were reaching the leaf nodes, how to remove it, we were sending back null to the function. When we are sending back null, okay, so when the parent calls are calling back this function, they are going to receive null. Okay, so what we are doing, we are calling this function. When we are doing the traversal, we are calling this function. Okay, FNC is our function which we are calling, short form for function. So whenever they encounter a leaf node, right, they are going to return null. Okay, so if it is going to return null, what is going to happen in that case, roots left will become null. For example, okay, let's take this example, 1 2 3 4 5 6 7. So what is happening is, this is the node, right, this is the current root. Okay, so root is going to call this function. There are inside our function 2 more recursive function calls are going to happen. So if this function call is going to happen, root is going to call its left function call. Now this guy, when it is going to return, since it is a leaf node, okay, it will encounter this condition, it's a leaf node, it's going to return null. So when it returns null, root's left will become equal to null. Okay, so this is the root, this guy is going to return null. So what will happen is, this node will be erased and this node will be erased, and root's left will become equal to null. Okay, this will be erased and root's left will become equal to null. That is a simple attachment that we are going to make. That means it doesn't have any children, its left is null. So that's why we have to give this return null. And similarly for roots right. Okay, if it is not a leaf node, nothing will happen. The same left which was passed, that will become the left. Okay, so it's very important to understand this. And once this is done, that's it. Let's submit and see if it's working. So it's working. That's it. Thank you for being patient and listen.